In this video, you will learn about the process of cracking, how it is carried out and why it is done. From our video on fractional distillation, you should know that crude oil is a mixture of hydrocarbons with different carbon chain lengths. Smaller hydrocarbons have a lower boiling point and are more volatile, making them easy to ignite and more useful as fuels. Larger hydrocarbons have a higher boiling point, are harder to ignite, therefore not as useful as fuels. We use a lot of fuels in our day-to-day lives, driving cars, aeroplanes, lorries and even heating our homes. This means there is a very high demand for small chain hydrocarbons. However, after fractional distillation, we find that we have a large supply of long chain molecules. The process of cracking breaks down long chain alkanes into a smaller alkane and alkene molecule. This allows the supply of short chain hydrocarbons to meet the demand for them, as the longer chain alkanes are broken down into shorter alkanes and an alkene. The alkenes are also useful as these can be used in the manufacture of plastics. Here is an equation showing that C12H26 is broken down into octane and butene. There isn't a set way that these molecules are broken down. In fact, C12H26 could also be broken down into decane and ethene, or even butene, pentane and propene, as these equations show. The large hydrocarbon is broken down in quite a random way. Just note that in each equation, of course, since we had 12 carbon atoms and 26 hydrogens going into the reaction, the same must come out. The process of cracking is carried out in one of two ways, either by thermal cracking using high temperature and pressure, or by catalytic cracking at low temperatures and pressures but using a catalyst. In thermal cracking, the large hydrocarbons are heated to temperatures up to 750 degrees C and a high pressure of 70 atmospheres. This high temperature and pressure breaks the bonds between carbon atoms to make smaller molecules. Catalytic cracking is the method used mostly in industry today. The large hydrocarbons are heated to around 500 degrees C and are passed over a zeolite catalyst. The catalysts chosen tend to break the bonds in the large hydrocarbons and make molecules of between 5 to 10 carbons in chain lengths, making them very useful in petrol. Now, at the end of this video tutorial, you should know that cracking is the process in which large alkanes are turned into smaller alkanes and an alkene molecule, and that there are two types of cracking: thermal cracking using high temperature and pressure, and catalytic cracking, which is the method preferred in industry as it uses lower temperature and pressure and produces more molecules that are useful in petrol.